Okay. So I'm kind of assuming here, I'm gonna pull up, here it is, got my notification. Just wanna confirm that the audio is working. Okay. So yeah, let me get rid of this. Hit done. Let me see, did I get everybody? Okay. He's still joining. And I'm gonna share my screen. This is good. Okay. So I'll be back to check attendance. I usually check it again at 2:15. So let me see as far as announcements. So we're in the home stretch, gentlemen. We have today, and then after today is only one more meeting, which is next Wednesday, right? So the intent for today is to go through exam 2, and then Wednesday next week I'd like to go through exam 3, and that'll be most of the stuff for the final. Let me remind everyone. Okay. Also, if you need my attention today, like the way I have it wired, I have my setup with a wired connection without a headphone, so I can't hear if you try to unmute yourself. So to get my attention, you have to go in the chat and get my attention in the chat. Let me see. So I want to remind everyone of the hard deadline of May 1st, which is a Sunday night at 11:59 p.m. going until Monday morning. All the old assignments lock out. So right now in this moment, you can still earn up to 90% on anything that's on Pearson. That means old exams. We have 3 of them. Old homework or old quizzes. All right. I did have a student that asked about, his grades in the course right now. So I guess I'll just kind of say the same thing for you all that I shared with the earlier students. So like if you're trying to get a sense of your grades, like basically how I'm going to calculate the grades and what you can do. Like for instance, if you take your highest score on exam 1, right? I think each exam is worth 20%. So we're going to say that times 0.2. Then we're going to say plus your highest score on exam 2 times 0.2 plus your highest score in exam 3 times 0.2, right? That's for the exams. Then we're going to say plus your homework average, all right? Your homework average, I think that's 10%, so times 0.1 plus your quiz average, whatever the average says in Pearson, I'm just going to take that score and plug it into this formula, times 0.1, and then plus whatever your highest score on your final exam is, times 0.2, right? So that's 20, 40, 60, 70, 80, 100, right? This is how I'm going to calculate your grade, right? So if you want to get a sense of where you are, you can take whatever scores you have on these exams, plug them into this formula. Whatever your homework average is, you plug it in, plug in your quiz average, and then try varying scores on the final, right? So like suppose you got an 80 on the final with your data, right? Then it'll spit out what your grade would be. So then suppose you got a 70 on the final. You plug in 70 with your data, and then you'll get a sense of the grade. So once you plug in your information into this formula and then play around with different scores on the final, you can get a sense of what you need to score in the final in order to generate whatever grade you want, right? So hopefully that was okay and that made sense and you can make use of that. Yeah, hard deadline is May 1st. So then when we hit May 1st at 11:59 p.m., again, all the old stuff locks out. 1 minute later, your final will become available. The only thing you're going to have access to is the final, right? So hopefully you've been taking notes. You have a notebook of like your work and, you can reference it, obviously. But if you're like disorganized or whatever, if you don't have a plan, then, you have to do the best that you can. Let me just check Zoom really quickly, see the chat. The chat looks good. Okay. So with that, yeah, that's pretty much it. I mean, again, we're essentially in the home stretch. So today what I wanted to do is go through as many questions from exam 2. So because of the way I set my questions up, basically I do a pool. Every time we take the exam, it's going to be different. So I'm just going to start at the beginning with you all, and it'll give me a different set of questions essentially than in my 9am course, because sometimes that happens, and I'll just open it back up at 2:15. So I'll check attendance again around 2:10, 2:15. I mean 2:15 in 10 minutes. Okay. So let's work on exam 2, which is chapter 3. I want to say on Wednesday, we got through as many questions from exam 1 as we could. Okay. So we're asked to graph the function on paper and then choose the correct graph. So 6 to the power of x, right? That's an exponential function. There are no manipulations. So the general shape of an exponential is like D, right? So that's the general shape of an exponential. So I'm going to go with that one. Sketch the graph for the following function. Describe how the graph can be obtained from the graph of the basic exponential function 2 to the power of x, right? So it looks like we have this 3 times 2 to the power of x minus 1 plus 1. So we have several transformations going on at once, right? So the parent function or the base function is an exponential function at 2 to the power of x. Then when we have multiple transformations in sequence like that, my recommendation is to work your way from the inside to the out. So you want to start with the innermost manipulation, identify that transformation, and then kind of work your way to the outside. So the innermost in this case will be the minus 1, right? Where we subtract the 1 on the inside of the basic function. So inside manipulations typically cause a horizontal change, right? So this, and it's the reverse of your intuition. Intuitively, you might think this moves in the negative x direction, but it's actually the reverse. So this moves in the positive x direction. So it moves to the right by 1, right? So then there's basically 3 transformations here. We go right 1, we multiply the outside by a number larger than 1 and outside by 3. So outside manipulations generally cause a vertical change. So that's going to cause a vertical stretch by a factor of 3. And then that plus 1 on the outside causes it to move up, right? So outside manipulations typically cause a vertical change. So then I'm going to click to enlarge the graph. If the base is the exponential, I'm going to click the third row on the left, and I'm just clicking anywhere in the graph. The base is 2. We said we went what? Right by 1. Nope, that was a 2. Right by 1. We also said we went up. Sorry. Yeah, we went up by 1. Okay. And then we said a vertical stretch by a factor of 3. Okay. I think that's it. So I'm going to go with that result. Close this out. Did I get it? Looks like I did not get it. Let me try that again. Like this, click on the graph, vertical stretch by a factor of 3. We're not reflecting. We went up by 1 and we went to the right by 1. Okay, let me hit save. Okay, that looks good. Describe how the graph can be obtained. Shift this graph. Let me see. We said we went right by 1. So it's either A or C. We stretched it vertically, okay, and then shifted it up by 1, right? So that's only A. Okay, let's go into the next question. Again, I'll check Zoom and attendance and everything in the chat in about 5 minutes, just under 5 minutes. All right. Write an equation of this form for the given graph. They gave us 2 points, and we want to model it. We want to model these 2 points on this exponential. We want to find an exponential model that fits these 2 points. Okay. So let me start by getting a copy. Let me see. Okay, I feel like that's a little bit better. I feel like this is even better. That's no good. I know the header is a little bit weird. Nope. No. No. Come back. Zoom out again. Ugh. It's not gonna let me do that. Okay. Well, yeah, this is what we need. So let's go with this. So I'm gonna get a copy of this guy. I guess I'll just take it from here. And like this. Okay. And then let's take this and drop it here. Okay. So let's see how to fit this data to the exponential model. All right, where did my pen go? Right here. All right. So let's start with the model that was given. So we have this f of x equals a to the power of x plus b, right? And then we have two ordered pairs. We have -2, 14 is 1 point on this model. And then we have this -1, 2, which is another point, right? So let's just plug these in, right? So for instance, when x is, let's do when x is, let's do the -2. So a to the power of -2 plus b equals 14. And then a to the power of -1 plus b equals 2, right? Basically, I just plugged in for x and y. Now we can say the first line minus the second, right? So let's say the first one minus the second one. So we're going to subtract, essentially distribute a negative across that row, okay? So then this will give us, let me see, a to the -2 minus a to the -1, the b's cancel, equals 12, right? And then let's kind of rewrite this a little bit. So this is the same as 1 over a squared minus 1 over a equals 12. With something like this, we can multiply by the least common denominator to clear the fractions. So I'm going to multiply both sides by a squared. All right, so this times a squared, and then this times a squared. I basically said the entire left by a squared, so I had to distribute the a squared, and the entire right by a squared, okay? So on the left, what this gives us, like this cancels this, so we get a 1. A squared divided by a is a. And then on the right, we have 12a squared, okay? Let me move everything to the right. So then this gives us 12a squared plus a minus 1 equals 0. This is not a perfect, now we could use a quadratic formula. Let's see. That might be the easiest way. Because basically we would be looking for two numbers that multiply to give us -12. No, okay. So actually, I think I'm going to use, so this AC method, right? Let me, like, okay. Let me think, what's the simplest one? So there, I use this technique called the AC method. I don't even know if that's an official name for it, but this is just how I factor something of this form if it can be factored. We're looking for two numbers that multiply to give us -12 and add to give us 1, right? So let's just kind of go through that list. If we look at -12. Now notice that -12 is what? 4 times 3, so -2 times 2 times 3, right? So then we're going to play with the factors until we find the factors that add up to 1. So then we can say the first one would be -1 and 12, but that adds up to 11. So those are not the two numbers. We can do -2. Now notice, if we've used this -2 already, we have 6 left over. These add up to 4, so this is no good. We can do -3. See, on the left here, I'm just going 1, 2, 3, all right? So then if we've used this -3, we have 4 left over. Notice this, these are the two numbers that add up, that multiply to give us -12 and add to give us 1. So these are the two numbers we were looking for. So then I'm going to use this technique called the box method to kind of proceed, right? So with the box technique, let's do, yeah, let's keep going. So with the box technique, it looks something like this. In the upper left-hand corner goes to 12a squared. The lower right goes to -1. And then on the other diagonal, we rewrite this a in the center using those two numbers that we just found, right? So we're going to have -3a and plus 4a, because 4 plus -3 is +1, right? So now that we've got this box filled in, what can we factor out of the two numbers in top? What's our GCF, greatest common factor? We can factor out a 3a. Okay. What do the two on bottom have in common? I think it's only 1, right? So we can only factor out a +1 or just 1. The two on the left, they both have 4a. So it looks like we could factor out a 4a from the two on the left. And then the two on the right looks like we could factor out a -1, right? So then our claim is that this 12a squared plus a minus 1 equal to 0 can be factored into the form 4a minus 1 times 3a plus 1, right? And then if we just FOIL to do a quick check, we can confirm that this actually works. 4 times 3 is what? 12a squared. 4a minus 3a is just a, and then -1 times 1 is -1, right? So we're confident in this factoring. Okay, so we're still solving for a. This is okay. So then now we basically set each of these factors, these binomial factors, we set them each to 0 and solve, and we'll get a equals 1/4 or a -1/3. Okay. So let's see. Yeah, and I think in this context, a negative base does not makes it so it doesn't behave like an exponential. So we're gonna scrap this result, and we're gonna go with a to be 1/4. So then let's take this second equation. So if a is 1/4, then if we plug it into the second one, which I feel like is a little bit easier, 1/4 to the -1 plus b equals 2. So then that's a 4, you subtract. So then b equals -2. So then it looks like our f of x should be 1/4 to the power of x minus 2, okay? So then before we submit it on the exam, we want to check. This is something that we can indeed check. It has the proper form, and then we just need to make sure that our original points work with this model, right? So for instance, when x is -2, that's going to be 4 squared, which is 16, minus 2 should be 14. So that one checks out. And then when x is -1, that's going to be 4 minus 2, which is 2. So both of these check out. All right. So we got 1/4 to the power of x minus 2. Let me submit this result, and then let me check out. I'll check the attendance for any stragglers. Ouch. Let me get again. Okay, let me see. Okay. So we got, okay, let's do like this, function like this. 1. Hmm. 1 Mississippi, 2 Mississippi, 3 Mississippi. Okay, let's try this again. No? Yeah, come on, keyboard. We're so annoying. All right, I'll just type it here. 1/4 to the power of x. I think we said minus 2. I don't know why it's doing that. Use integers or fractions for any number in the expression. And then when we plug 2 in, so when x is 2, now looking at the graph, when x is 2, it looks like it's almost -1. So when x is 2, so that's 1/16. Type an integer or simplify a fraction. So it's 1/16 minus 2. Let's see. 2 over 1, 16 times 2 is 32. So 1 over 16 minus 32 over 16 is a -31/16. negative, so we got negative 31 by 16. Okay. So notice that's really close to negative 2. That's what we anticipated by looking at the graph. And I think we had to count our tick marks, right? I think I said negative 1, but it's actually negative 2. Because you got to basically count the tick marks to confirm that. Okay, let me hop back over to Zoom really quickly and see if we got any stragglers. Okay, we do. Let me get them. Let me stop the screen share. Okay, got them. Hit save. Okay. All right. If you're just joining us, let's see. So we were actually kind of, let me just share the screen. Start the broadcast. And if you have a question, you have to put it in the chat. The way I have it set up, I won't be able to hear the audio. We'll probably do a couple more, and we'll see what it's looking like. Kind of working through exam 2 as best we can. I feel okay with that result, so I'm just going to go on to the next one. Find the principal P that will generate the future value A where this compounded annually for 9 years. Okay, let's get a copy of this. So we're going to take it from about here. This is fine. All right, so let's look at this one. This one is an example on compound interest. Okay. All right. Oof. So we're asked to find a principal that will generate the future value where, okay, find a principal, and it says compounded annually. So if we're doing compound interest, we just need to make sure to use the right formula. This one should work where the future value A equals P times 1 plus R over N to the power of NT, okay? So we're solving for P. Let's list out what's given. So we want the future value to be 11,000. 8% is our rate. So the rate is 8% as a decimal. I'm gonna go ahead and write it as a decimal. If it's compounded annually, that means our N is 1 and the time is 9 years. Okay. So then if we plug all these pieces of information in, so then we're going to have 11,000 times P times 1 plus the rate, which is 0.08. Compoundings per year is 1 times 9, right? So this is essentially just 11,000 equals P times some number, right? So then to solve for P, we divide both sides by whatever this number is. So then let's do it this way. Okay. All right. So then we're going to say 11,000, 11, 1, 2, 3, divided by, we got what? 1.08 to the power of 9. This should be fine the way we have it written. I mean, typed. Oh, not 1.8, 1.08. And here, just to kind of be a little bit more meticulous, I'm going to insert a parentheses here. And I'm going to put one here. Okay. 11,000 divided by that number. Okay. So it looks like we need to start with, or is approximately $5,502.74. So with those conditions, if we start with this amount in 9 years, we would have earned, the account should have grown to 11, the 11,000 that we needed. Okay, let's hop back here, this one. Okay. So 5827.74. Okay. All right, let me go check Zoom. Write this in log form. I'll do it in just a moment. Okay. So, all right. So there was a question that came up. What day is the final? So with the final exam, basically what I'm doing, I'm going to do it the way that I did last semester. Before last semester in the past, it was a common final and there was a day. Well, because I was doing completely remote last semester, I'm just going to, basically what we're going to do is, so all of our old assignments are going to lock out on May the 1st at 11:59 p.m. That's a Sunday night going into Monday morning. 1 minute later, when it's midnight on Monday morning, your final exam should become available on Pearson, and you'll have access to it until the end of the week, right? Whatever the due date should appear. So everything old is going to lock out, and the only thing that you're going to have access to is the final. So that should become available on that Monday at the start of the week of finals. So next Wednesday is the official last day of class, and then the following Monday starts the week of finals. That's when, pretty much at that moment, is where the old stuff will lock out, and you'll have access to the final for the week. You get unlimited attempts, but when it's due, that's a hard deadline, because when it's due, I got to calculate grades and submit grades. So that's the long and short of all of that. Write the equation in its equivalent logarithmic form. Okay. So then to rewrite, where'd it go? Let's go like this. So to write this here, let's try this. Let's turn it off for right now. So to write this in the equivalent log form, basically the base swings over, the base of the exponential becomes the base of the log. So this would be what? Log base 2 of 8 log base 2 of 8 equals 3, right? And we can check that we did this correctly. We can do something like the following. Hey Siri, what's the log of 8 divided by the log of 2?
I found some web results. I can show them if you ask again from your iPhone.
Just send it to my phone. What's the log of 8 divided by the log of 2?
Okay, I found this on the web for what's the log of 8 divided by the log of 2. Check it out.
Okay, she's tripping. I got it here. So if we said the log of 8 divided by the log of 2, it should be 3. Okay. Okay, let me check Zoom one more time. Cool. Okay. So I'm going to go ahead and submit what I have. I think, people got what they needed, so I'm not going to hang around because nobody's there. We can convert this to a log equation. If the base swings, it's going to be log base S of 144 equals 2. Oh, now it's doing this thing, function this. Okay. exponential form. So it's going to be use integers or fractions for any number. So then it's going to be 64 to the power of 1/3 equals 4. So those are quick. This is going to be 8 to the power of 1/3. So the cube root of 8 is 2. So then 2 squared is 4. 4 plus 5 is 9. So it looks like the result is 9. Okay. And then I'm going to check this in my calculator, and then I'm going to call it a day. So to check in the calculator, I would do something like the log of the square root of 9 minus 5. Then we're going to say divided by the log of 8. So that's called change of base. I'm going to hit math as a fraction, and we should get a third. Okay. All right. I'm going to go ahead and submit. That's fine. Submit the test. We did 8 questions. Oh, we got something wrong. Number 4. Let's look at number 4. Let's see. 8%. I think I may have did 9% for some reason. Or I know 58, 74. Let's see. The principal. Let's see. 11,000. Can we just pull it back? It might still be in there. Let me see. So when we had the 11,000, we can see what we did wrong. If it's still in the calculator. Oh, see, I did 10,000. No, was that a different one? Maybe that's a different one. Let's keep going back. I gotta start over. Oh, maybe that might be as far back as it can go. Okay. Compounded annually. Let's look at it here. Wait a minute. Okay. Yeah, maybe I just typed the wrong thing. 27. I don't even know how that happened. Because like I think I wrote the right thing, because you can see it here. Yeah, somehow there was a disconnect. We have the right answer, but we just typed the wrong thing. Okay, well, I don't feel so bad about it. Okay, so if there aren't any burning questions on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your weekend, guys. Good luck with everything. I'm available if you have questions. You know how to find me. Okay, guys, take care. Peace.